Well, thank you for attending. I'm Craig Gresbrink. I'm a solutions architect at 24 Hour Fitness. I've been a solutions architect for 8 years. And for the last year and a half, I've been the product owner of what we call the cache team or the grid team. And what I'm here to present is, in 2017, I was up here presenting, and I had a vision of how we would integrate with a SaaS billing system. And what I'm presenting today is exactly what we built based on that vision. So I'm going to show you who I am, or who 24 Hour Fitness is, what we built, why we built it, which is very important, a little bit of the details on how we built it, and then some learnings or things I wish I would have known before we got started that would have saved us some time. 24 Hour Fitness, we have about 400 gyms in 13 states across the United States, and we serve nearly 4 million members. We have an employee base, most of them part-time, of about over 20,000. So now we'll get into what we built, the high-level architecture and a little bit of infrastructure, just to give you some idea of what we have in place. All of our applications at 24 Hour Fitness are pretty much built like this, with a UI on top. It could be an external vendor calling our APIs. Our ESB will return or expose web services that our applications will call. And then in turn, on the right, you'll see that we have data services, and those tend to query databases. But what we built to integrate with our SaaS solution, which you see up on the right, and this is multiple SaaS solutions, but in particular we'll be talking about our SaaS billing system. We built cache loaders that read data via or get data or acquire Delta data from our SaaS systems, and the cache loaders do get JCache puts into our grid, and then our applications called data services that also expose web services, and those do queries against the grid. And then we'll get into a little bit about continuous queries in the grid and what those are, but real quickly, they're sort of like database triggers, detecting data change events, and we'll get into some use cases on how we used continuous queries. Infrastructure is not my specialty, but I gathered this information, and if there's any infrastructure questions, I can certainly bring those back and get you guys the answers. But we're running a 7-node GridGain cluster on the Ultimate Edition, and we've set it up with each node is a virtual node, has 8 CPUs, and then 64 gigabytes of RAM. We segment the RAM into durable memory, or what I would call off-heap memory, 45 gigs, and that's where all of our data that we'll talk about today is stored. And then we give the JVM 14 gigabytes of memory, and that's where the SQL processing occurs. It'll take data and move it from that durable memory into the SQL engine to run queries against it. And then we have 5 left over for operating system and various other things the system needs to do. This is our SaaS billing system object model that they present to us. Each one of these objects is, you can think of it, if you're from a database background, think of each object as a table. In GridGain's terms, each object's a cache. So we're caching each one of these objects via those cache loaders into the grid. We're a subscription management company. The SaaS billing system is a subscription management company, or subscription management system, and that's why you see we have what we'll call a member account. You guys see the cursor? We call that a member account, and then members have subscriptions, and subscriptions have charges. And over on the right side, we have invoices, or the billing and payment side of the SaaS system, which is how we collect money from our customers. Wanted to give you a little bit of insight into the volume of data that we have. I'm doing a keynote tomorrow, so you'll get a little more information on how we rolled this system out, which will tie it all together. But for now, I wanted to highlight, we've only been live for about 6 months, but we already have 8.2 million rate plan charges, which are those things that we charge on the subscriptions, the monthly fees, you might think of them. Could be annual fees, any other incidental things. And then the side of this object model that I expect to grow even more, the left-hand side, the subscription and accounts are pretty static. We have 4 million members. They have X number of subscriptions, but the right side, the billing and payment, will grow dramatically over time as we continue to bill our customers. And right now we already have, I'll show it right here. Invoices have invoice items on this model, and we have 9 million invoice items that we're querying against. And we're joining all of these tables together, so that's something we'll get into. Another high level, just showing that we're not just putting our SaaS data in. In the keynote, they talked about a converged database. We consider the grid to be, I guess, a converged, I would call it data repo or a data storage platform. So we are storing our billing system. This data, like I said, cache loaders put that data into the grid. We also have a customer identity and access management system, and that uses a different approach of near real-time webhooks, and that will also put that data, and by put I mean insert and update, or upsert in database terms. That will keep the data in the grid in sync with our external customer identity and access management system. I also wanted to show other ways that the grid gets accessed. I've talked about data services quite a bit, and cache loaders putting data in, so putting data in and querying it. And I talked a little bit about continuous queries, or our listener continuous query tier, but I did want to touch a non-prod on the bottom right. Our QA team has automation tests, and those are running Ready API to query data to decide to get the data in the right category to use for their automated test. And we're using JDBC from that tool to query the grid as well. I should say our data services use Ignite thick client nodes, and that's how they're querying the grid, but we'll get in more details on that in a minute. And then off to the bottom left, we have we call it Data Fabric Admin, but that's our term. GridGain calls it their web console. And so we have that in all of our environments, and that's where BAs or product owners and anybody trying to support the system, and in development, developers are writing their queries and testing them and running ad hoc queries against the grid. So that's 4 different ways of things that are interacting with the grid to build our transactional platform. So why did we build this? This is pretty complicated. If you see all these blue boxes, these are all new things we built in the last year and a half. So why did we build this? The main reason is our SaaS vendors, we've done about 4 or 5 cloud or SaaS vendor integrations, and every one of them has come with API constraints, is what I would call them. Almost all of them have, I'll jump to number 3, have rate limits. In other words, the number of concurrent calls or the number of calls per minute that they'll let you do before they start failing you. Like I mentioned, we have 430 clubs. We operate 24/7. With some of our systems, we've determined the volume would make us hit the API rate limits. So that's one reason why we get the data in the grid, so all of our queries can go against the grid and not go against or not utilize the vendor's APIs, so we don't hit rate limits. Some vendors have slow and chatty APIs. I'll talk more about that in the keynote, but chatty just meaning to create 3 objects, you gotta make 3 different calls, or to query 3 different objects, you gotta make 3 different calls. I put slow and chatty together because chatty is the 3 or 4 or 5 or 10 different calls it takes to do something, but when you put slow on top of it, I consider that a double-edged sword, because slow times 10 is 10 times as slow. So sometimes it didn't meet our SLAs for our applications. One of our vendors was not guaranteed to be up 24/7. We're a 24/7 business. It wasn't that it's contractual that they can take it down 2 hours per week for maintenance. In reality, they haven't done that, but to protect the business, we needed our, in this case, employee data in the grid so we can make our sales 24/7, 7 days a week. We and our business does not like 2 hours of downtime for making sales. And then another one I want to talk about is, this is with our SaaS billing system, is some of the APIs will let you find Craig Gresbrink's account, and they'll let you pass in a full name. But what if you want to find all customers or members or member accounts that have the last name of GRE%, like a like clause? Some APIs don't allow that, and that's what we found. And then down at the bottom, the single data store, I guess I might change it or to tie it into the keynote. The converged data store has benefits, letting us query and run queries and support and even write queries that transactionally that go against data from multiple different systems, an HR system, a SIAM system, a billing system, all in the grid. We can write one query accessing all of that data. And then the other thing is, in-memory data grids are fast. You could probably do a lot of this in a converged database or a traditional file database that stores or is not memory first, a non-in-memory database, but the grid is very fast and scalable. So I have some examples of timings on that we've been able to achieve. How did we build it? We broached cache loaders, data services, and continuous queries a little bit, but I'm going to get in a little more detail. But before I do that, it was mentioned in the keynote by Nikita, there are some complexities to a distributed in-memory data grid. I would suggest you strongly consider, if you're going to do something as large and complex as we decided to do, and you're going to run your enterprise on it. We're running our club check-in, member check-in to our clubs, our sales and member services are all reliant on the grid. So our enterprise is running on the grid, and that's just 3 apps. We really have 10 or 12 different apps using it, but for simplification, I left those out. But I would strongly consider getting a GridGain support contract and utilizing their resources, unless you like to refactor. But a quick timeline of how we did this, I mentioned it. I gave a presentation and had a vision for us getting around hitting our SaaS billing systems API rate limits. I started evangelizing it and saying this is the solution I think we need to go to, but it was kind of dismissed. And then we got into the light clauses in Q3, and as soon as I tried to do member search and look up customers with a last name of JOH and first name of T%, it just wasn't possible. So that's when the grid came into being. And then we went live with 2 clubs, so we've had a phased rollout, and that'll become important in the rest of my presentation. As we went from 20 clubs to 40 clubs and migrated data from our old billing system to our new billing system, things were going pretty well. And then we started hitting an issue, namely full table scans. Now we've been SQL tuning, and I'm largely to blame for that, and I'll discuss that more on how we got into this predicament. But with a 2-club pilot, full table scans weren't an issue at all, so we kind of knew we were taking some shortcuts and we would have to go back and make this system work for 430 clubs and 4 million members, and that's actually what we're doing now. And I'll show you the details on that. Some code type stuff. You can configure GridGain caches. If you haven't configured a GridGain cache, you can do it in XML, which I'm kind of showing at the top 2 lines here, but I don't want to get into how do you configure object caches in GridGain. You can also do it in Java if you would like. We chose to use XML. But most importantly is our object caches are loaded via puts, and in some cases, if all you needed was an account object, we'll use a JCache get from cache, because it's faster than a SQL query to get just a single object. But I would say 90% of our data services are joining multiple caches or multiple tables. And in that scenario, I wanted to show what do you have to do to take an object cache and make it SQL queryable. It's actually fairly simple. You'll see you define the query entity or the fields, and you call them fields, but you're really listing the attributes on your object. And we chose to expose every attribute on our objects and not pick, well, there's 12 attributes, we only want to expose 4 or 5. There's no penalty to exposing more. And at the pace we have 11 teams in 3 different countries over the last year and a half building functionality on a brand new billing system and a brand new object model. And we couldn't really predict which of those 12 fields in that example they might need, and we didn't want to keep adding 1 field at a time because it would slow down development. So that's a choice we made. But so you just list your fields, and then we'll talk a lot about indexing, but it's as simple as defining that you want an index on some of those fields. And I show the account ID or the subscription ID, which I'd consider the primary key in database terms, and then we have a foreign key. The subscription is a child of the account. We will index the foreign keys as well, or the join columns. a little bit of Java code on how we get this to work, and how we hide some of the complexity. Complexity was a big topic. We, in conjunction with GridGain support, you'll see, let's start with the bottom. We created our own query object, and notice this query object only really takes 2 attributes: a string of the SQL query, and it takes a distributed joins true or false. GridGain's SQL query object has things like timeouts, enforced join order. There's probably 20 different attributes that you could have set on this. We didn't want our 11 development teams and 80 developers all using the grid in many different ways. So we have a team of about 3 people who are building this framework, and I guess the cache team understanding what the capabilities are and exposing the right capabilities to those teams at the right time. And then you'll see at the top, we could have had all those teams and each service that was built, operate against the GridGain APIs, but we chose to use the facade pattern in conjunction with GridGain support. And here you see that we happen to use an EJB in our data services tier, and all the data service wars use that EJB to run their query. And so none of those wars that get deployed, or we have about 40 different wars doing queries through that EJB, none of them are at all aware that they're using a GridGain or Apache Ignite. They're just using our EJB. So I strongly suggest abstracting that out if you're worried about the complexity or the possibilities of things you can do interacting with the grid, getting out of control by your teams, and you want to constrain that, then consider creating some sort of facade in front of grid interactions. Here's the GridGain web console. You can use it to run SQL queries like any SQL client, Toad or SQL Plus, if you're familiar with those. I didn't really show that, but imagine the query up here on the top. You can hit execute, it'll run the query, give you the result set. That's what our developers are doing to test their queries, and if we're debugging an issue in production or in any environment, we can join multiple tables and debug that way with this SQL client. But what I'm showing here is SQL tuning. We just started using this as of late for the reasons I kind of alluded to. You can hit this explain plan and you'll see what is Ignite or GridGain going to do, or how is it gonna execute your query. And we can see here that it's going to use the invoice item subscription ID index, which is what we want. And I guess you'll see a theme that get familiar with this and don't let too much development go on before you do SQL tuning, and we'll see why. But before that, some of the complexity. If you're familiar with this, this is gonna make a lot of sense. If you're not, I guess my main reason for bringing this up was it's a complex topic. Don't go off building anything. I think Nikita called it, consider how you co-locate your data. That's what this is all about. Distributed joins, affinity domains, and co-location of data. They're all, to me, different but very, I almost would say, for the sake of this presentation, synonymous terms that you need to understand if you're putting data from multiple data sets into your grid, because it can affect performance. I stole this from the GridGain website. On the right, we see what a co-located SQL query does. It basically takes your query, sends it to each of the 3 nodes, we have 7, and runs that query, and returns the result set, and then aggregates it, and now you have your answer. Very fast, very efficient. You can go from 7 nodes to 20 nodes, horizontal scalability of your cluster, no problem at all. And that's distributed joins of false. If you say distributed joins of true, then you're saying, I want GridGain to make sure that all my data for this query is not necessarily sitting on one node, and that's the affinity portion of this. And so you can see that that query, when it runs, node 1 has to ask node 2 and node 3, do you have any of the data I need to respond to this query? And same, node 2 has to ask node 1 and 3, node 3, 1 and 2. And that may not seem too bad with a 3-node cluster, but when you go to 7 to 20, the performance of that query will degrade because of the network communication between the different servers. And we'll talk about how to get around that if you need to. I want to go back real quick because it's a little confusing. Distributed joins true is what we said in the Java code, in that facade that runs the query. On the admin tool, it's called allow non-co-located joins, and it's a checkbox. So that's where how you create, and then affinity keys are what you set or define in your cache or your objects to get them to co-locate. So that's how all three of those pieces of the puzzle work together. Like I said, that might be confusing, but the goal is if that doesn't make sense, don't go off building your domain model without understanding what affinity is, distributed joins, and co-located queries are. For us, if you look at this model right here, on the left, a member has an account, and I would say 90% of the time that the account that has the subscription is also the account that pays the invoice, but 10% of the time it's not true, because I could have a membership or a subscription, and I have a member account with my name on it, but my mom could also have a member account. That's why you see account and account. And my mom could be paying for my subscription, and the invoice owner is actually her account. So that gets into, we have to treat these as two different affinity domains, and we do multiple queries. We'll do a query on the left side, get the IDs, and run a second query on the right side with distributed joins false, or we'll do the vice versa to get maximum performance and scalability out of the grid. Again, I kind of alluded to this, but we have our customer identity and access management system. That data is in the grid. Our billing system has affinity domains. We also have member check-in. We're storing all of our member check-in data in the grid. And we also have the bio enrollment data necessary to, when you scan in at the clubs, to match you up to who you are before we check you into the grid. So we're going to expand pricing into the grid as well, membership sales pricing. So we're getting more and more different affinity domains into the grid. Here's a diagram of, a simplified diagram of what we have now, but we have SIAM data, and then we have billing and payment and accounts, and they're separate affinity domains. We can run queries that join the bio-enrollment data to the billing systems account data. They are the same affinity domain. They have an affinity key tied by the account ID, and so that's how that's done. Real quickly, the product catalog is a real small set of like 2,000 tables, so we replicate that, and that means it can be used in any distributed joins false query because its data exists on all 7 nodes. It has a very small memory footprint. So system of record, I alluded to this, but we're actually storing for our member check-in app. We have your bio-enrollment data in here, and we have your every club check-in that you do is saved here. And the key is, it's here and nowhere else. It's not in a SaaS system, it's not in a database. So we are using the grid as a system of record or as an in-memory database. But what does that mean? Well, if you're going to use it in that capacity, you got to ask yourself questions that you would ask for any database. How do I back it up and how do I restore it? And that's where we were on the GridGain Enterprise Edition. To use it as an in-memory database, we are on the Ultimate Edition, and that gives you those capabilities. The other reason I want to broach on real quick, obviously a system of record or using it as an in-memory database is one reason that you might use a data grid, but I showed you the 9 million invoice items, and that's after 6 months. A year and a half from now, it's going to grow to 25 million. So the question became, yes, our grid is not the system of record for our billing data, but what if something were to happen? How could we restore the production grid with that much data from day one? Could we call that SaaS vendor's APIs and get millions of records? And how long would it take? Would it take 6 hours, 1 hour, a day, 2 days? Would it crash our systems in the middle? The cache loaders and things, would they run out of memory? We didn't want to answer that question. So in reality, the reason we went to Ultimate is we want to, if that were ever to happen, we will restore from our backups, as we'll talk about. We will not be reliant on our cache loaders, our SaaS billing system. We will use the Ultimate Edition backups. We've also turned on native persistence or ignite persistence. We actually run a 7x grid from 5 years ago holding club and employee data. That is all in memory. There's no native persistence. And that means if we shut down that grid, all the nodes in that grid, and bring it up, it'll be completely empty, won't be able to service requests, and we'll have to run external programs to go grab it from the various system of records or databases and put it in the grid. With our 8x grid, we've turned on native persistence, and that means we can take down all 7 nodes, we can bring up all 7 nodes, and 15 seconds later we will start servicing queries and requests against that grid. Albeit, that data won't all be in memory yet. It takes a while to hydrate, but we will be selling and we will be servicing requests. So without any, like I kind of alluded to, without going to external systems to try to load that data.
Is this what you're referring to with the 45 gigs of RAM in the node?
The 45 gigs would be, yeah, we have to hold all the questions to the end, but real quick, the 45 gigs is to hold all the data you're seeing here. Those 9 million invoice items, our SIAM data, our club check-ins, and any other data or object caches we decide to create. That's where the 45 gigs, 45 times 7, of course, because it's per each node. So just a little bit about our backup and recovery. I'm going to go real quick because every business has different tolerances, but it's going to illuminate one point. We do nightly full backups, and then the Ultimate Edition has incremental backups, so we do hourly incremental backups. In addition to that, the Ultimate Edition has point-in-time recovery. So, what time is it now? 11? If I wanted to get to last night's data and restore to last night, I could just use a nightly full backup. If I wanted to get to 10 a.m., I could do a nightly full backup, and then I would apply the hourly incrementals, 10 of them, to get to 10 a.m. But if there was a data corruption at 10:45, maybe a developer deployed some code and the update statement cleared out all the data in a given cache. They didn't do it update by primary key. They forgot the where clause. It slipped through code reviews, whatever it may be. And they did that at 10:45. If I want to get to 10:44 and 50 seconds, then I would do the same thing. Nightly backup, 10 hourly incrementals, and then I use point-in-time recovery to get me to 10:54 and 50 seconds to the point of corruption. And now I may have lost a little data depending on how long it took me to, if it's 11 a.m., maybe 15 minutes of data. I got to figure out what to do with, but I can get as close as possible to the point of corruption. We hope that never happens. We do rigorous code reviews, as you'll see, for SQL tuning reasons and otherwise. We happen to retain these backups for 5 days, but like I said, every business is different. You'll have to do what makes sense for your business. Continuous query, again, that's the database trigger or detecting a insert or an update or a put on the grid. And just like a database trigger, you can look at individual columns, old and new values, and decide to throw an event or do something based on that event. So here's an example of one way we've used it, is imagine that an invoice gets paid in full, and you don't want to run a query tomorrow and thank that person for making their full payment. You want to detect that that invoice gets paid and send them an email or a confirmation real time. You could do that in your application, sure, but another way to do it is you have various applications making payments and affecting the grid. We just pull the data in every 15 minutes from our SaaS billing provider, and when we detect that event, we know an invoice was paid in full, and we go ahead and send an email to the customer. We have various other use cases, probably 4 or 5 now, and they just keep growing of where we're using continuous query. So now we're getting into the learnings, or things if you embark upon this, I hope you can take away from this and not make the mistakes that I led the team into. So this is all GridGain documentation on their website. I had read it. What indexes aren't free, we know that. They take up memory. They slow down your inserts. They slow down your updates and your deletes. Not really a problem for 24-hour fitness because we don't do a lot of volume of insert, update, and deletes. We do a lot of querying. In my past, I would say, let's index invoice balances. So now I can ask, how many of my customers who joined in the last month have an invoice balance greater than 0 on any invoice. Basically, they haven't paid us. We don't actually do that in our transactional system, but I was afraid that somebody in that web console might ask that question and run that query, and I thought, I'm going to invoice the invoice balance due and the create date on the invoice. So by doing that, it's kind of alluded to here in bold, GridGain documentation again, the optimizer might do more harm than good and choose the wrong index when it runs your query. And that's exactly what we saw. And I'll talk about what our new strategy is. So I kind of talked about this. I was used to Oracle. Oracle's optimizer is more sophisticated than GridGain's optimizer in terms of choosing which indexes. So just know that going into it. Consider this standard that we emerged into, which was we actually dropped some of those in. Actually, the code review I did yesterday before I flew out was us dropping that invoice balance due index. It was providing no value, and it was causing other queries to not use the correct indexes. So we're in the process of cleaning up and getting back to this standard, which is a pretty simple standard. Index your IDs, or what you might consider your primary keys. For us, most of the objects in our billing system, the ID, it's called ID, so that's easy. Your natural keys, or what I'd refer to as your foreign keys, or the things you're going to use when you join the tables together. Definitely index those. You're going to be joining your tables together, no brainer. And then natural keys, we do a lot of that with like a social security number or an email or things you look up a member account with that are natural keys. Even the last name, we have last name uppercased and we index that as well. But in our billing system, we have like member numbers and subscription names. We use those a lot. So natural keys are definitely something you should index. And then the fourth one you need to consider if this is a transactional system or sort of an HTAP system. Are you going to be running batch jobs against it? Currently we are, and that's why we have some of our dates we're indexing. And that's so we can run things like show me all customers who purchased personal training yesterday and have not been contacted by the club. So CRM data is coming into the grid, purchase data is coming into the grid, and we know that haven't been contacted by the club. Email those people and send them the phone number so they can call. We don't do that. We do that nightly. So how do you know who purchased in the last day? You need indexes on your purchase dates in your system. I will say be careful, because if you have any transactional queries that have that date, purchase date in that example, in their where clause, it might start choosing that index. We scan all of our code base before we create those data indexes, and we send emails out to the team, hey, is anybody concerned with this? That's our new standard to make sure we are not causing any problems with our existing queries. Like I said, I showed you an explain plan. We didn't do explain plans at first. We kind of were loosey-goosey on a 2-club pilot with 20,000 members. It didn't really matter that much. Now, every new query that's written, every query that's updated, and we're retrofitting, as we'll see, our existing queries that are doing full table scans. We are doing explain plans and code reviewing those and making sure that we have the right indexes in place, it's using the right indexes, and this thing is going to perform as it should. And we'll get into some performance in a little bit. What do you do if it's not using the right index? You can consider dropping indexes. We're doing that, as I alluded to. But one thing you can do in that example where you have an index and you decide to create a data index and you find that that index exists in your existing production queries, you may have to, if you really want that data index and this query starts using it, you may have to use a hint. Now, just like in Oracle, it's a hint. It's called that for a reason. It may not use it. You need to write this, you need to put it in the web console, you need to hit explain, and you need to verify that it is using the index you want it to use, namely the one you specified. This is from our APM solution, or our application performance monitoring tool. And we're looking at several different web service endpoints on our Get Subscriptions web service, a data service. And one thing that should jump out at you is 862 milliseconds, is not too slow. I mean, that's not causing any of our clubs or anybody using our applications to say, wow, this system's slow. But compare it to these other web service endpoints below it and notice all these web service endpoints are under 10 milliseconds. This one's probably running 1 query. This one's probably running 2. That's why it's 735 milliseconds. And this one is 100 times, or let's see, like at least 800 times more, much slower. So this is fast. And this is a theme I'm going to try to say. We thought slow was anything over 3 seconds, but we're starting to think slow is anything over 50 milliseconds for our data services. So this one jumps out. It is doing full table scans. We're actively tuning it, and we'll talk more about that. GridGain out of the box will set the long-running query timeout to 3 seconds, and we had thought everything would bubble up past 3 seconds, and then we would say that's something we need to tune and sort of a little bit reactively tune, and that didn't really pan out, so we've dropped it to 500 milliseconds. Like I said, we believe anything over 500 milliseconds is doing a full table scan. This is showing proof of it. When the query takes longer than 500 milliseconds, it logs in the server log. We are scanning the server log, and that's what you're seeing here. And every 10 minutes, we're detecting how many full table scans are we doing. And our goal is to get the full table scans down to 0. That's how we're going to get a system that can handle the data growth we're going to put on it over time. And so that's what we're seeking to do. And like I said, most of that was stuff we should have done in advance and made sure it was using the right indexes, but we didn't do that. So now we've got to go back and do that. Here's an example of a query we've actually tuned, a web service endpoint. It's very similar to the other one, but this is kind of real time over the hours or over a few hours. We tuned a query that was doing a full table scan, taking still not terribly slow. Nobody would have complained from SLA response times, but it was taking 800 milliseconds. And then we tuned it to use the right indexes, the right join indexes, and made it so it did no full table scans. And as soon as we deployed it, you can see that right here, at 11:54, we deployed that web service to production, and our application performance monitoring tool notes that it's declining, and from there on out, it's taking 5 milliseconds to run that data service. So that's the power of query tuning. You might ask, well, if response times aren't bad, then why did you have to tune it? Shouldn't you only tune something if it's causing you a problem? Yeah, it was causing us a problem. When you get volume of these calls, and I talked about it before, it is, in doing a full table scan, it is literally taking those, let's say, 1.5 million account objects and taking them from durable memory or off-heap memory, putting them on your JVM heap memory, and running the query and asking garbage collection to clean that up. Seems to be doing fine until we start throwing 100 per 10 seconds at it. And the example I use is if I ask you, you have 2 hands, you can carry 2 pieces of paper, and I start throwing papers down one by one every 10 seconds, and you have to bring them to, let's say, a trash can that's right here. You can probably do that if every 10 seconds I do that. But if I start throwing 200 papers at you every 5 seconds, and you only have 2 hands to get them there, this whole room's going to fill up. So that's what happened. The garbage collection couldn't keep up with the amount of objects we're putting on heap, all because we're doing full table scans. So it's not necessarily a grid thing, but one, because you don't want to do full table scans in any database that has high volume with large tables. So it's not a grid thing, but it can be hidden by the speed of this in-memory grid. We thought, like I said, we thought it was going to bubble up. It didn't bubble up. It didn't even come on our radar. It was perfectly fine, except for it started running the JVMs out of memory. And then we realized we need to do SQL tuning. So that's kind of where we're at now. Other ways you can find long-running queries is the GridGain Web Console. They have a running queries tab. You can tell, well, let me say this. Again, the default of this number is 3 seconds. This is from our production system. If I set that to 3 seconds now, 3 months ago, the queries would have shown up. If I set it to 3 seconds now, nothing's showing up. We've done enough tuning, nothing even showing up over like 1 second, I believe. But again, wanting to impress this point, 61 milliseconds, not too bad. These 966 millisecond queries that are running, full table scans. We need to tune those. So another way to find real time by monitoring your grid with the web console queries that are taking too long. And notice I had to set it to 0 milliseconds, so I'm seeing, or 0 seconds, I'm seeing all the queries that run true. run through the system, but it's not really all queries because some of those 3.5 millisecond queries are so fast that they're not, this thing's polling, it can't really show them. So that's okay because I really don't care about those tuned queries. I'm looking for the ones that are over 50 milliseconds, real time as the application's running. Once you have that, you've got this query history tab here, and you can set up your caches to have query history, which we have done. We can go in, find the queries that are offending. We can see their volume or how often they're running. We can click on them, and then we can see the explain plan real time and eyeball it. And so that's kind of what I've been doing. Full table scan, or why is it using the invoice balance due index when it should be using the invoice account number index to get real specific. But just want to make you aware those tools are out there to help you SQL tune. So some high-level key takeaways. You can use the grid as a key value object cache with JCache operations, puts, gets. We use that for data loading. It's very fast at data loading. Our SLA is to get the delta data from our billing system and load it into our grid in 15 minutes or less, and we do that every 15 minutes. We are using puts on every single object, and so far we haven't had to go tune the, what I'd call the upserts or the puts into the grid at all. It's performing very fast across 23 different caches. You can use it as a system of record, meaning you have no database backing it. You'll need the Ultimate Edition to do that, to back up a distributed system and get a consistent state. That's what the Ultimate Edition gives you. And another reason you might use it, it's kind of alluded to, it's probably a theme of this whole summit. I'll talk a little bit more in my keynote, but you might consider to use it to future-proof your company. Any questions? That was a lot. There's got to be something. Yes?
How many machines do you have in the cluster?
We have 7 nodes right now.
Each one has like how many CPUs?
8 CPUs.
How do you handle changes to your object model across the nodes?
Changes to the object model. That is a good question. We are able to add columns to the objects and make them SQL queryable very easily. When you do that, only your new puts from your external system will have that field set. So oftentimes, I would say 90% of the time, we want it back from day one historically if we're adding a new column. But that may not always be the case. It may be a new column in your system of record that's not populated historically. So that's one thing. We've been okay with that. That hasn't caused a problem. We can remove columns. Our biggest gotcha is trying to change the data type of a column. GridGain's recommendation was to version the cache or create a new cache. We've often went to the easiest thing, it's kind of kludgy. They created a birth date column in the SIAM cache and they made it a string. A little bit hard to query whose birthdays are in the next week. So they created a birth date to attribute. Obviously, over time, we'd like to get rid of everybody using the birth date, and it'll take a little bit of time. We could have created another version of that cache. Happens to be a 4 million object cache, and I don't really want double the footprint and that, so we just we're moving pretty fast at 24 Hour Fitness, as you'll see in the keynote tomorrow. We tend to go right now with the path of least resistance. Our goal is to SQL tune this, as well as add functionality to our applications and get ready for Q1, which is our biggest sales and member check-in or customer check-in time for us. So that's what we're really focusing on. Does that answer your question?
So in those cases, the XML that you showed with the configuration is at the attributes and everything. Does that get updated if you have a
Yeah, that's actually a good question. When we create a brand new cache, it's all XML based. When we add that column or remove it, we run, I guess they're H2 commands, but we're running alter statements like in a traditional database to add indexes and columns, but we also have to keep the XML in sync because when you bounce that, it's doing a consistency check with your grid. So we actually run the alter statements and change the XML and do those and deploy it all as one deployment to get consistency. That's also helpful. You might say, why don't we just do alter statements for everything? Well, it's kind of nice if you have the XML and you're building a local grid as a developer and they don't run any alter statements. They just take the latest code bases, run them. They've got their caches created with the right indexes and columns, the latest state. So actually that consistency check can cause problems, but it's also helpful because it forces you to do the right thing. Where it can cause problems is when you do those kinds of things, it's always good, especially not, bounce your tiers that have that XML. Make sure they're consistent because it does the consistency check when you start up the service. So we have had cases where we changed something and a day later we bounced this tier. Consistency check failed and we're like, well, what just happened? Well, we should make sure it's consistent at the time we make the change, not 3 days later. Yep.
Okay. What are your top 2 or maybe 3 lessons learned on this journey?
Lesson learned, well, I mean, one big one obviously is the optimizer is not as sophisticated. SQL tuning is important. That would probably be our biggest. I would say using GridGain support, they pointed us in a good direction to give us something that 3-person team could give to all the other teams and build upon for 8 months that we really haven't changed, really at all. That SQL query you saw with the string and the distributed joins and that facade, we haven't changed really at all, so that was definitely good.
Do you run any algorithm on your data set to infer something like closely connected people, advertising, etc.? Can you share a little bit?
So I run an algorithm on the data set to...
Like some sort of algorithm other than just query, where you're trying to infer some intelligence.
Oh, sort of like some analytics on them, on the data? We haven't done a whole lot of that. The grid is pretty new and we're pretty focused on transactional, just the sales and servicing of the customers and checking them into the clubs. But I do hope to make it more of an HTAP system. It has a lot of data that you could ask right now as we sit here in the club that's closest to here, whatever it is. What's the demographic of the members in that club right now? We have all that data in the grid. We just haven't exposed that and integrated it with our BI systems. As you can imagine, replacing the billing system, our BI systems are all of our reporting and analytic historical. It's a good time to switch them over, but they're in a pretty state of disarray. Just playing catch up to what we've done and pulled the rug out from under them. You were hitting this billing system, but now all your data is over here and the structure is completely different. So I think that's it. I'll be around. You can come and talk to me after, maybe outside, or stop and grab me as I'm walking around. And thank you very much. Enjoy the rest of your day.